In 1915, every airplane on Earth was made of wood, wire, and stretched fabric. Canvas over wooden frames held together with steel cables tensioned by hand. The machines looked like kites that had been given engines and dared to carry men. They were fragile. They warped in rain. They rotted in storage. They caught fire on impact. A hard landing could crack a spar. A storm could peel the fabric off a wing in flight. Pilots trusted their lives to structures that a carpenter would have recognized and a shipwright would have rejected. This was not a temporary limitation. This was the entire state of the art. Every aircraft designer in every country on Earth accepted it. Wood was light. Wood was available. Wood was what airplanes were made of. The question was never whether to build with wood. The question was which species of wood to use. One man looked at this consensus and saw it for what it was, not a law of physics, a habit. His name was Hugo Junkers. He was 56 years old. He had never designed an airplane. He had spent his career building gas engines, water heaters, and calorimeters. And on December 12, 1915, at an airfield outside Dessau, he flew the first all-metal airplane in history. The machine that made every airplane after it possible was built by a man the aviation industry had never heard of. Hugo Junkers was born on February 3, 1859 in Rieth, a town in the Prussian Rye province near Menangladbach. His father, Johann Heinrich Junkers, owned a cotton weaving mill. The family was wealthy. Hugo and his 6 siblings received educations that most German children could not dream of. He completed his secondary schooling in 1878, attended the Royal Polytechnic University in Charlottenburg, then transferred to the Royal Technical University in Aachen, graduating in 1883 with a degree in mechanical engineering. He did not go into aviation. Aviation barely existed. The Wright brothers would not fly at Kitty Hawk for another 20 years. Junkers went into thermodynamics. He returned to Wright to work in his father's company, then attended advanced lectures on electromagnetism and thermodynamics in Charlottenburg under the physicist Adolf Slaby. Slaby placed him with the Continental Gas Company in Dessau, where Junkers worked on the development of opposed piston gas engines. The work required precision. To optimize a gas engine, you needed to know the exact energy content of the fuel you were burning. No reliable method existed to measure it. Junkers built one. In 1892, he patented a calorimeter, a device that measured temperature differences in precisely controlled volumes of water as they absorbed heat from burning gas samples. The instrument eliminated the guesswork that had plagued gas engine development for years. In 1893, Junkers personally presented the calorimeter at the World's Columbian Exposition in Chicago. It was awarded a gold medal. Most inventors would have stopped there. Junkers kept thinking he had created a system that efficiently transferred heat from a burning gas flame to flowing water. The measurement was specific to the calorimeter. The heat transfer mechanism was universal. He saw a commercial product inside a scientific instrument. In 1894, he patented a gas-fired bath boiler, not a storage tank that heated water slowly and lost energy while it sat. A tankless heater. Water flowed through tubes positioned directly in the flame path. The burner ignited when someone opened a tap. It shut off when the tap closed. Instant hot water. No waste, no waiting. In 1895, Junkers founded Junkers and Company in Dessau to manufacture the heater. He had one investor, Robert Ludwig, who provided startup capital. The business succeeded immediately. Junkers repaid Ludwig's entire investment within 2 years. The tankless water heater became one of the most successful consumer products in German industrial history. Within a decade, Junkers' heaters were installed in apartment buildings, hospitals, and hotels across Germany and beyond. The brand name Junkers on a water heater meant the same thing it would later mean on an airplane. Reliability built by an engineer who understood heat transfer at a level his competitors could not match. In 1897, he accepted a professorship in mechanical engineering at the Technik Hochschule in Aachen, where he lectured for the next 15 years, while simultaneously running the company in Dessau. He patented gas stoves, pressure regulators, fan heaters, and oil engines. He founded a private research institute, the Versuch Zahnalt Professor Jonas, funded entirely from his company's profits. He established additional companies in the mechanical engineering sector. He filed dozens of patents. By the time he turned 50, Hugo Junkers was a wealthy industrialist, a respected professor, and one of the most prolific patent holders in German mechanical engineering. He had not touched an airplane. In 1908, everything changed. Hans Reisner, a German aviation pioneer and engineer at Aachen, had been developing an all-metal aircraft. He needed corrugated iron wings manufactured to a precision that no ordinary metal shop could achieve. Junkers and Company in Dessau could. Junkers built the wings. The collaboration pulled him into aerodynamics for the first time. He was 49 years old. Junkers did not dabble. He constructed a wind tunnel. He studied airfoils. In 1910, he patented a cantilever wing design with a thick profile and no external bracing. No wires, no struts. The wing's own internal structure carried all the loads. Every other airplane in the world used external bracing to hold the wings in place. Junkers proposed eliminating it entirely. The patent was radical. It described the structural philosophy that would define commercial aviation for the next century. Then the war intervened in 1914. The German government conscripted Junkers and his factory for military production. He was ordered to build aircraft. He did not want to build weapons. He was a pacifist, a man with socialist sympathies who believed technology existed to connect people, not to destroy them. The government did not care what he believed. It cared what he could build. UNAS built on December 12, 1915. The Junkers J-1 lifted off from an airfield near Dessau. It was a monoplane constructed entirely from sheet iron, later replaced with sheet steel. No wood, no fabric, no external bracing. The test pilots nicknamed it the Bliesel, the sheet metal donkey. It was heavy, weighing significantly more than comparable wooden aircraft. It was slower than the biplanes the military favored, but it flew, and when it landed hard, it did not splinter. When it sat in the rain, it did not warp. When a bullet struck it, it did not catch fire like canvas. The military establishment was unimpressed. The generals wanted fast, agile biplanes made of wood and canvas. The J-1 was a slow, heavy monoplane made of metal. It looked wrong. It sounded wrong. It violated every assumption the aviation world held sacred. Junkers did not care about assumptions. He cared about physics. Wood warped. Metal did not. Wood rotted. Metal did not. Wood burned on impact. Metal survived. The J-1 was not an operational fighter. It was a proof of concept. A technology demonstrator built as a private venture. The concept was that the future of aviation was metal. Every designer who dismissed it was defending a material that was already obsolete. They simply did not know it yet. By 1917, Junkers had refined the design into the J-I, a two-seat armored ground attack aircraft with a metal fuselage that formed a protective bathtub around the engine, pilot, and observer. The armor shielded the crew from small arms fire during low-level missions over the trenches. The German military ordered 227 of them. It was the first all-metal aircraft to enter mass production anywhere in the world. The government forced Junkers into a partnership with the Dutch manufacturer Anthony Fowler. The partnership was hostile. Fowler wanted access to Junkers' metal construction techniques. Junkers wanted to be left alone. The collaboration dissolved after the war, but not before producing the DI, the world's first low-winged, single-seat fighter aircraft and the first airplane built entirely from duralumin, the aluminum alloy that would become the standard material of aviation for the next 80 years. The war ended on November 11, 1918. Germany was defeated. The Treaty of Versailles imposed brutal restrictions on German aviation. Military aircraft production was forbidden. The Allies destroyed thousands of German warplanes. The entire military aviation infrastructure was dismantled. Hugo Junkers saw this not as a disaster, but as a liberation. He had never wanted to build weapons. Now the treaty compelled him to build what he had always wanted to build. Civilian aircraft machines designed not to kill, but to carry people from one place to another in safety and comfort. In early 1919, Junkers instructed his chief designer Otto Reiter to develop an aircraft purely for civilian use. 6 months later, on June 25, 1919, test pilot Emil Mons lifted the Junkers F-13 off the runway at Dessau. It was the world's first all-metal passenger aircraft. Every other airplane of the era was built from wood and covered with linen. The F-13 was constructed entirely from corrugated duralumin, a low-wing cantilever monoplane with no external bracing, an enclosed heated passenger cabin that seated 4 people in comfort behind large windows. The pilots sat in an open cockpit because aviators in 1919 still believed they flew best when exposed to the elements. The passengers, however, rode inside a sealed cabin like civilized travelers. Junkers named the first prototype Hera after his oldest daughter,